Hello, and welcome to another class, another week where we meet here on YouTube to bring you practical and theoretical tips that will help you on your journey to become a climatronico, that is, to learn how to repair any electronic board, even if you've never seen a board in your life. And on top of that, make 2, 5, 10, 15, or even 20,000 reals a month with this type of repair. My name is Lawander, and I am a climatronico engineer. Today's lesson: air conditioner tripping the circuit breaker problem you encounter a lot, something you come across often, and we're going to show you what to do about it in today's class. So that's it. Subscribe and let's get started. Inverter air conditioner tripping the circuit breaker. You arrive at the unit, you arrive at the client's place, you turn on the unit and it trips the circuit breaker. Understand this behavior. Let's consider some hypotheses here. First, it hits the circuit breaker, it drops. It hits the circuit breaker, it drops. There's a clear short, right? There's a clear short circuit. In this case, you need to analyze, is the unit powered at the evaporator or at the condenser? Let's assume it's powered at the evaporator. In that case, you go to the evaporator because the short is already there at the evaporator. Why? A unit that's powered at the evaporator only activates the condenser. Condenser comes on after a while. So the phase only reaches the condenser after some time. So you don't even look at the condenser when the unit is powered at the evaporator, okay? So if the unit is powered at the evaporator, that's what you do. If the unit is powered by the condenser, then it could be either of the boards, it could be either part of the unit, either the condenser has something shorted or the evaporator has something shorted. Where's the short? Yeah, closing phase and neutral. When I close phase and neutral, there is a short circuit. Some component in the circuit has shorted and is tripping the breaker. The current will rise so much that it trips the breaker. So if you flip the breaker and it trips again right away, it's because there's already a clear short. What should you do? You should start disconnecting the peripherals. And what are peripherals? Sensors are peripherals, fan motors are peripherals, the compressor is a peripheral, everything that connects to the board is a peripheral. Okay? Why? Because if there's a short in a peripheral, it will keep tripping the breaker. And the problem isn't necessarily with the board. The issue could be with something that's connected to the board. If something is connected to the board, that could be what's causing the short and the malfunction. It's not necessarily the board itself. Not every time you analyze a short or tripped breaker, remember, when the breaker trips, it's a short, right? If the breaker trips, there's a short. It's not like this. I arrive at the machine, the breaker, if the breaker tripped, there's a short. No, you should turn the breaker back on and then turn on the machine. There's a second scenario. When you turn on the breaker, it doesn't trip, it stays on as normal. You turn it on, then you go and turn on the machine and wait for it to run. Why? Because sometimes the breaker tripped due to a voltage drop and nothing was damaged, it actually protected the system. Understand? Because that's its function. The breaker's function is to protect the system. It serves to protect the system. So if it operates correctly, it will protect the system, and that's it. Another important detail, check the breaker. Sometimes the breaker itself might be faulty, right? Be suspicious of the breaker as well. Sometimes it might be faulty, especially if it keeps turning on and off, on and off. If you turn it on and it holds, the machine beeps, starts up normally and everything, but when you let go and it trips, then the problem is with the breaker, okay? So yeah, that's important. Because in general, the breaker is supposed to trip to protect the system, not just to show that there's a short circuit in the system. All right, assuming the breaker is fine, right? Assuming it's okay, you flip the breaker, the machine beeps, it works, you turn it on, it starts up the evaporator, and then when the relay clicks and it trips, where's the problem going to be? Over at the condenser. The relay clicks and it trips, where's the problem going to be? At the condenser. See what I mean? The relay clicks, it trips the breaker. The problem is at the condenser. What are you going to check at the condenser? What are you going to check at the condenser? First thing, this guy here, the first thing is to check the compressor. The first thing is to check the compressor. Disconnect it, take it out here. See? Disconnect it from the system, do the same procedure, turn the system on. The relay clicked now, but it didn't shut off. The compressor is shorted. Did it trip again? Then you're going to remove this guy, the fan, whether it's from the evaporator or the condenser, okay? You're going to remove the fan. You're going to remove the fan, whether it's black or BLDC. Disconnect it and turn the machine on again without the fan. Is the short circuit still happening in the condenser? You're going to remove the sensors. Remove the sensors. Turn it on again and let it if the breaker trips again. There's no problem. Okay? It's normal for the breaker to keep tripping if there's a short in the system. You're tracking down the short circuit. Keep disconnecting what's connected to the board and tracing the short. Be careful when removing the reactor, because when you take out the reactor, it won't turn on, right? In many cases, it won't turn on because it needs the reactor to start up. It needs this little guy here to turn on. So if you remove it, the short might disappear, but actually it only disappeared because the unit didn't turn on. I'm still working on the condenser board, okay? So if you remove the sensors, disconnected the compressor, and taken out the fan, you've removed the fan, sensors, compressor, and it still trips when the evaporator relay clicks. Or if it's powered at the condenser, like this Fujitsu here, you've already removed the compressor, fan, sensors, or you can remove the reactor, which will already shut off the condenser board, or you can disconnect the power cable if it's powered at the condenser. If it's powered at the evaporator, you're going to remove the phase that goes to the condenser. You're going to disconnect one of the boards, choose either the evaporator or the condenser. For example, let's suppose I disconnected the condenser, turned on the circuit breaker, and it kept tripping. The problem is in the evaporator. If I disconnected the condenser and it kept tripping, the problem is in the evaporator. In fact, that's the first step you should take. It's easier, right? I powered it up, got there, turned on the circuit breaker, and the system tripped again. Just disconnect the phase from the condenser. Done. I isolated it, left only the evaporator, turned it on again, and the evaporator started up. The evaporator turned on normally. Great. So the short isn't in the evaporator, it's in the condenser. I go back to the condenser and disconnect the evaporator, and I'll work only on the condenser. Then I'll remove the compressor. I take out the compressor, and I'm going to test it, right? I'll test it. Let's see what happened. Text. Then for each peripheral I remove compressor, fan, sensors, you test again. So you can know where the fault was. Because if you remove everything and the problem disappears, it could be a short. You won't know. You get it? Remove one, test. Remove one, test. This here, look, I'm not even talking about using a multimeter to test, because if after you remove it, you can use a multimeter to see if it beeps, see if there's continuity, but that's not the case here. It's even simpler. It's about narrowing down the fault. At the time, I remove all the peripherals, so it's important. It's worth emphasizing. With evaporators, be very careful with the ionizers, humidity sensor ionizer, and antibacterial devices. You know those little parts that connect to the evaporator board? I've come across a lot of those boards, those devices, the ones that connect to the evaporator board, shorted out and taking down the whole system. And understand, many of these boards, most of them, work without these components, without the ionizer, without the antibacterial device. You can disconnect it from the board, and the board will run without it. Again, it's also a peripheral. This is the case when you remove the evaporator and the short disappears, or when the short is in the evaporator. Then you go to the evaporator, remove the fan, and the short remains. You remove the sensors, and the short remains. What's left? There's only that little ionizer you forgot about. You remove it, the short disappears, and the board works normally. It was the one killing the board. So if you've removed everything and forgot that little detailed ionizer, it could be what's killing your client's board and tripping the circuit breaker, right? So be very careful with all the peripherals. Ideally, if you're going to disconnect a board, just remove the phase wire from the terminal block. Just remove the phase wire here from the terminal block, see? To make repairs, disconnect the phase, supply phase and neutral to the machine, right? Keep it powered, just disconnect the phase going to the board and turn on the circuit breaker. Then, after you turn on the circuit breaker, you go and check if that board you left powered up will trip the circuit breaker again or not, right? So, in general, the short circuit could be in the compressor, the sensor, the fan motor, the ionizer, right? It could be on either board. At the time, I disconnected everything, man. Only the boards were left and the circuit breaker kept tripping. So only after all that, it could be the board, remember. It could also be the circuit breaker. Then it could be, then you narrow it down to the board. If it's the board, what are you going to check? If it's the board, what are you going to check? First, you're going to test a few points. Let me show you very quickly. Right over here, just take a look. You're going to be looking for the rectifier bridge components. If there's only one, if there's more than one, oh, I don't know how to find the bridge. I don't know what a rectifier bridge is. So it's this little component here, look. It has this little shape here. You're going to take your multimeter, set it to continuity mode, the beeping scale, and touch the probes here, or with it turned off, the system power down. Touch the probes, and if it beeps, you found the problem. Actually, let's go, first point. Is it the board? Without touching, don't know anything about boards? Take it to a professional technician. Do you know how to work with circuit boards? Yeah, that's the deal now. Just to be clear, this isn't for you. Rectifier, bridge, or the power capacitors. Once you've identified the large capacitors, you're going to, again, turn off the machine, wait for the capacitors to discharge, wait 10, 15 minutes, then you can work on the board, right? Or discharge the capacitors using a series lamp with a discharge lamp. A lamp like the ones from the store, right? With two little wires at the ends, you use it to discharge the capacitor. Once the capacitor is discharged, I'm going to measure continuity. If the capacitor is beeping, here's your short circuit. If the rectifier bridge is beeping, whether it's in this model here, look, this Elgin model, here's the rectifier bridge. See, it's covered in thermal paste. If there's an IGBT, you're going to measure the IGBT, you're going to measure the power diode. You check continuity on all the components that are on the power heatsink. There you go. That's the master tip. Measure the continuity of all the components that are on the power heatsink. Between the pins, they shouldn't beep. If it beeps, if there's continuity, 0 ohms, it beeps, there's a short circuit. That's where the short is. That component is shorted. Then you should remove the component, replace the component, right? Or power it up without it to see if the short goes away. Or when you remove the component, go to the board and measure the board. If the short remains on the board, there's still another component shorted. If the short is gone from the board and it's in the component, that's the component that's shorted, right? So, to recap, today's lesson is a bit quicker. There's not much more for me to say about this. It's very straightforward. Inverter, air conditioner, tripping a circuit breaker. First, is the circuit breaker good? Check the circuit breaker. Leomande, assuming the circuit breaker is fine, you're going to eliminate the evaporator, disconnect the phase from the condenser, and power only the evaporator. If the circuit breaker stays on, then the short is in the condenser. If the circuit breaker trips again, then the short is in the evaporator. Then if the short is in the evaporator, it's worth swapping to see if there's a short in the condenser as well. Power only the condenser. But how do I swap it, Leomande? Just remove the phase wire from the terminal block, man. Let the phase and neutral from the electrical system coming from the circuit breaker stay connected, and just disconnect the phase that goes to the evaporator or the phase that goes to the condenser. All right? If it's powered at the condenser, if it's powered at the evaporator, and when you turn it on the circuit breaker trips, the fault is in the evaporator. Because when it's powered at the evaporator, it takes a while before the condenser is powered. It's not immediate, okay? To narrow down which board is shorted, then you'll remove the peripherals. Remember? Today, you learned what a peripheral is. The compressor is a peripheral, the fan is a peripheral, the water pump is a peripheral. Over there in the cassette, the level sensor is a peripheral, the temperature sensor is a peripheral, the reversing valve is a peripheral. You're going to disconnect everything that's connected to the board one by one and keep testing, because you'll find the component that's shorted. The fan will trip the circuit breaker. The compressor will trip the circuit breaker if it's shorted, right? If the components are shorted, remember? In the evaporator, the ionizer, if the ionizer is shorted, it will trip the circuit breaker, okay? So, depending on the case, I would even remove the display. I would even remove the display from the board, depending on the case, to narrow down the fault. If you've ruled everything else out, then the fault is on the condenser board. You look for the rectifier bridge, you look for the components that are on the heatsink. Rectifier bridge, IGBT, diode, IPM, power capacitor, large capacitor. If the fault is on the evaporator board, you look for the rectifier bridge capacitors, right? The voltage input section there. Usually, the rectifier bridge shorts out. Generally, it's the rectifier bridge or the switcher in the switching power supply. All right, everyone? Look, if the air conditioner is tripping the circuit breaker, now you know what to do. The step-by-step process you need to follow. Which components you need to check so you won't get stuck anymore. You already know the procedure. You know what to do when the inverter air conditioner is tripping the breaker. See you in the next class, class number 300, Tuesday at 8 p.m. on this same channel. Subscribe if you haven't already. See you in the next class. God bless. Take care. Thanks.